I am Mr. Rizallah, Math teacher. In this session, we will learn how to solve two equations in two variables by using the multiplicative inverse of the matrix. Let the two equations are a1x plus b1y equals c1 and a2x plus b2y equals c2. Therefore, the matrix equation, it will be matrix of the coefficients a1 p1 and a2 b2 multiplied by the matrix of the variables x and y equals the matrix of the constants c1 and c2. It means matrix A multiplied by matrix X equals matrix C. And so the solution set is the matrix X and Y equals the matrix A1 P1 A2 P2 raised to the power -1 multiplied by the matrix C1 and C2. Examples. Number 1. Using the multiplicative inverse to solve the two equations 2x equals 3 minus y and 3x minus 5 plus 2y equals 0. Solution. First of all, we must put the two equations in the form. The variables in one side and the constant in the other side. It means first equation, it will be 2x plus y equals 3. And the other equation, it will be 3x plus 2y equals 5. Since the matrix equation is matrix A multiplied by matrix X equals matrix C, it means matrix A, which is the matrix of the coefficients of the variables, multiplied by matrix X, which is the matrix of the variables, equals matrix C, which is the matrix of the constants. Therefore, the matrix 2, 1 and 3, 2 multiplied by matrix X and Y equals matrix 3 and 5. Now we find the determinant of the matrix A, which denoted by delta, equals 2, 1 and 3, 2, which equals 2 times 2 minus 1 times 3, it will be 1. Therefore, the multiplicative inverse of the matrix A equals 1 over delta multiplied by the matrix A after change the elements of the main diagonal and change the signs of the other diagonal, which will be equals 2, -1 and -3, 2. So multiply both sides by the multiplicative inverse of the matrix A from the left hand side. It means A -1 times A times X equal A -1 times C. It will be the matrix X equal the multiplicative inverse of the matrix A multiplied by the matrix C. Therefore, the matrix X, which is matrix X and Y, equals multiplicative inverse of the matrix A, which is 2, negative 1, and 3, 2, multiplied by the matrix of the constant, which is 3 and 5. Performing the multiplication of the two matrices, therefore the matrix X and Y equals the matrix of 1 and 1. It means X equal 1 and Y equals 1. Therefore, the solution set equals the set of ordered pair 1 and 1. Double I. X plus 2y minus 4 equals 0 and y equals 2x plus 1. Solution. First of all, we must put the two equations in the form, the variable in one side and the constant in the other side. Therefore, the two equations will be x plus 2y equals 4, that's equation number 1, and the other equation 2x minus y equals negative 1. So, the matrix equation A times x equals C, therefore the matrix of 1, 2 and 2, negative 1 multiplied by the matrix of the variables, which is x and y, equals the matrix of the constants, which is 4 and negative 1. Now we calculate the determinant of the matrix A, which is denoted by delta. Delta equals determinant of 1, 2 and 2, negative 1, which will be negative 5 differ than 0. Therefore, the multiplicative inverse of the matrix A equals 1 over delta multiplied by negative 1, negative 2 and negative 2, 1, which equals 1 over negative 5 multiplied by the matrix negative 1, negative 2 and negative 2, 1, which will be equals 1 over 5, 2 over 5 and 2 over 5, negative 1 over 5. Therefore, the matrix of the variables x and y equals the matrix 1 over 5, 2 over 5 and 2 over 5, negative 1 over 5 multiplied by the matrix C, which is 4 and negative 1. By performing this multiplication, we will get the matrix 2 over 5 and 9 over 5. It means the solution set, it will be the set of ordered pair 2 over 5 and 9 over 5. Example, if f of x equals ax squared plus b passes through the 2 points 2 and 0 and the other point -1 and -3. Use the matrices to find the values of a and b. Solution. Since f of x equals ax squared plus b passes through the point 2 and 0, therefore by substituting 0 equals a multiplied by 2 squared plus b. Therefore 4a plus b equals 0. That's equation number 1. And also this function passes through the point -1 and -3. Therefore it satisfied. Therefore -3 equals a multiplied by -1 power 2 plus b. It's equals a plus b equal -3. That's equation number 2. Now we need to solve these two equations, equation 1 and equation 2, to find the values of a and b. The matrix equation of these two equations equals 4, 1 and 1, 1 multiplied by a and b equals the matrix 0 and -3. Let the matrix A capital equals the matrix 4, 1 and 1, 1. Therefore its determinant equals 3. Therefore multiplicative inverse of the matrix A, which is the matrix of the coefficients of the A and B, equal 1 over 3 multiplied by the matrix 1, -1 and -1, 4, which will be 1 over 3, -1 over 3 and -1 over 3, 4 over 3. Therefore the matrix of the variables, which is A and B, equals A minus 1, which is 1 over 3, -1 over 3 and -1 over 3, 4 over 3, multiplied by the matrix 0 and -3, which will be 1 and -4. Therefore A equal 1 and B equal -4. Example 3. Use the matrices to find two numbers whose sum equals 10 and their difference equals 4. Solution. Let the two numbers are x and y. Therefore x plus y equal 10. That's equation number 1. X minus y equals 4. That's equation number 2. So the matrix equation, it will be matrix of coefficients, which is 1, 1 and 1, -1, multiplied by the matrix of the variables, which is x and y, equals the matrix of the constants, which is 10 and 4. Now we calculate the determinant of the matrix of the coefficients A, which is denoted by delta. Delta equals determinant of 1 1 and 1 negative 1, which will be negative 2, and it's differ than 0. So multiplicative inverse of the matrix A equals 1 over negative 2 multiplied by the matrix A after change the elements of the main diagonal and change the signs of the other diagonal, and we will get the matrix half half and half negative half. Multiplying equation number 3 by the multiplicative inverse of the matrix A, which is A negative 1 from the left side. Therefore, the matrix of the variables x and y will be equals half, half, and half negative half multiplied by the matrix of the constants, which is 10 and 4. After performing this multiplication, we will get the matrix 7 and 3. Therefore, the two numbers